Hey guys, welcome back to my channel. So today let's discuss another DSA problem. Best time to buy and sell stock. It's another Leetcode problem. So in the question we have an array given, array of prices, and that represents the price of a stock on each day. So for over a span of 6 days, you will see the prices, fluctuate for a particular stock. So that is what we see here. And what we need to do is we need to get a maximum profit. And how we will get a maximum profit is like there's a simple rule of the market, or not only of the stock market but of any market. Like if you want to have a profit margin, that you need to buy at a low price and sell at a higher price. So that is what we need to do. And also we need to keep in mind that one day we can just do one transaction. That is, if today you're buying something, then you can sell it off only in the next day. And also we have to see if we can achieve profit. It can happen that we might not achieve profit, so that time we have to return a 0. So for example, the given example that we have 715364. So before we want to sell and gain a profit, we need to buy it. So the very first number of the array that you see, that will be the very first number that we used, the buying price, for the very first time. So this is our buying price, and if you see, all of these numbers are kind of less than that. So we can't expect any profit, because for it to be profit, your selling price has to be greater than your buying price, meaning that in one of these days the price of the stock should be greater than 7 in order that we get a profit. But that is not happening for this particular example, so we get a 0 in this particular case. And then if we consider, suppose let's consider this as the buying price. Then the very next day we see a profit, 5 minus 1, 4. And the other day, if you see, it's 2, which is less than 4, so we might not consider it. Then again on the next day we see the price has jumped to 6, so 6 minus 1 is 5, so we will update this 4 to 5, and that is the maximum profit that we will be bagging for this. And again with 1 and 4, you see the difference is 3, which is still less than the maximum profit that we've gotten, so we'll leave it at 5. And similarly the same thing needs to be done with these numbers, that if we are considering this as the buying one, like the price at which we bought it, but then this will take a lot of time, right? And this is something that you have to consider in your head, because this is something we consider when we are trying to write a brute force method, where we have to consider each and every price and compare this with this, and this will be compared with 3, 6, 4, 3 will be compared with 6, 4, and all. That will be very time consuming, and you will maybe you have a very large array, and definitely you will get a TLE or something that is not expected out of the question. So there are efficient solutions to handle this, and so let's see. So considering this very example, I drew a graph of how it would look like with these fluctuating prices. And here you see that like we bought it at a price of 7, let's say, rupees, and next day we see that it became 1. That's why I've given it with a red line. And the other day we see that it jumps to 5. Great. Then again it drops to 3, then it goes to 6, and then it goes to 4. So like what I want to basically show here is the margin thing, or the profit which we are talking about. It has to be from the lowest point of the graph to the highest point of the graph. Now you might say that this is the highest point of the graph, but we are not going back in time. It has to move in this direction, right? We bought on this day, and then like we saw that maybe the price was like lesser 2 days back. We can't do that. Things don't run that way. So like this is the margin, or the profit margin, that we are gonna get or consider. Now let's quickly do a dry run. So the buying price is, as I mentioned, the very first element of the array will be the very first buying price, so it is 7, and that time you won't have any profit or factor the maximum profit. Next, you see that 1, okay, or the next number in an array is less than what we have as the buying price, so we are going to update it. Okay, again, no update in the profit, no update in the max profit. Next, we are going to see that the value, the buying price has become 5. Okay, sorry, not buying price, the price of the stock has become 5, but we have bought it at 1, right? And now the price is 5, so profit, so 5 minus 1 will be 4, so this becomes 4, and this also becomes 4 because we would be updating max profit at the same time. Then 3, but again we are sitting at the buying price of 1 and we need something less than the current buying price, and right now in this particular array we see that we won't be seeing that, so like we just have to so this does not gets updated as of now. And so when the price of the stock is 3, we see that 3 minus 1 is 2, but we have a better profit mapped, so we are not doing anything about it. Next, we have 6, so we have a good margin. 6 minus 1, that is 5, so this gets updated, this also gets updated. Then we have 4, and we would get like 3, but we have a better one, so we are not going to update it. So that is how we are getting a maximum profit of 5. Okay, hoping you understood this. Let's quickly code it. So we will have a buying price, that will be the very first element of our array. Then we have a profit. Then we will run a loop from 1 to the entire length of the prices array. And if the price on the other day is less than what we have, then our buy price, we are going to update the buy price. Else what we need to do is we have to calculate the profit, because if the price is greater than the buy price, then we are having a profit. So prices I minus buy prices, buy price, and the profit is max current profit, and we need to return the profit. Return the profit. Okay, let's run this. Okay, it's taking up some time. Okay. Great. So hoping you guys understood this question, and before I forget, the time complexity is O of n, because we are traversing towards like through the entire array once, and space complexity we are not using any such space, so it's O of 1. Okay, so O of n is your time complexity. Okay, and O of 1 pair space complexity. Okay, thank you so much for watching this. Let's catch up in the next video.